Hello everyone. Today we'll be solving a Google Kickstart round E question, shuffled anagram. Let's just read the question first. Let S be a string containing only letters of the English alphabet. An anagram of S is any string that contains exactly the same letters as S with the same number of occurrence of each letter but in different order. For example, the word kick, K-I-C-K, has an anagram as KCIK and CKKI. Now let S of I be the ith letter in S. We say that an anagram of SA is shuffled if and only if for all I, S of I is not equal to A of I. So for instance, KCIK is not a shuffled anagram of KICK as the fourth and the first letter of both of them are the same. However, CKKI would be considered a shuffled anagram of KICK and as would IKKC. So, given an arbitrary string S, your task is to output any one shuffled anagram of S or else print impossible if this cannot be done. Okay, so now let me just try to explain the question once. So given any string S, suppose S is start, so anagram would be a string containing these letters START in different order, but the number of occurrence of all letters should be same. Therefore, TTARS is the anagram, and SATRT is the anagram, but not a shuffled anagram, because in shuffled anagram, as specified by the question, the corresponding position in the new string should be different. Therefore, S in, suppose this is the shuffled anagram, in this position we cannot have S, and anything other than S we can have. Therefore, we can have T here. In this position we cannot have T, so we can have S here. In this A position we cannot have A, but we can have anything else. So let's have T only. At R we can have A, and at last we can have R. So this is a shuffled anagram. So I think now we are clear with what the question is demanding. So given any string, we have to either print any of the one shuffled anagram, or we have to print out impossible if it is not possible. Now let's think in the case when it is not possible. So basically, whenever any character in a string, whenever any character in a string has occurrence more than half of the size of string. For example, if we have AAB, then we can't have a shuffled anagram, because it would either be BAA or it would be ABA. In both of these cases, we have a position in which both of the position have the same letter. So it can't be a shuffled anagram. So the only case when a string can't be a shuffled anagram is when any of the character has occurrence more than the half of the size of the string. So now let's see how we can solve this question. To solve this, we can use multiple approaches. One is be backtracking. Um, One would be backtracking, and the other would be a non-backtracking approach. I'm not sure what to call it. I think when you think of it, you would feel like it's brute force, but it's better than backtracking. So let's just briefly discuss backtracking, and then we can discuss the other method, which I'll be showing the code of also. So what we are trying to achieve with backtracking is to create a shuffled anagram from the given string. Suppose we have a string start. Okay. Now we need to create a shuffled anagram from that. So in backtracking, what we do, we pick any of the character to start with and then go ahead with that. So suppose for the first position, we pick any character other than s. Suppose we take t. So we pass this t for now with the leftover characters. So we have SART. Now for the second position, we would pick something. Suppose we pick S here, and then we will pass this TS into the recursive function with the leftover characters like ART. Now we put any of them. Suppose we choose R for the third character. So we'll pass this TSR with the leftover R and T to the recursive function here. Suppose, A and T. Suppose we pick A here, then we would pass T, S, R, A and T. Now we find out that if we are only left with T, and if we put it there, then we won't have a shuffled anagram. So in this case, what we do, we backtrack to the last step where we chose A, and instead of A, we will choose T this time, and call the recursive backtracking function once again with this as a parameter and A as a leftover, and then we see whether we can put A here or not. If we can do, then we would get a shuffled anagram like so. So this is a backtracking approach of it, which is fine, but I would like to show you guys a simpler way to do it, which is more easier to understand and even easier to code. Let me clear this up. I don't need to clear this up. Okay. Now let me show you another, I think, more intuitive approach. So what we have as START as a string. So in this approach, what we will do, we will create another string. Suppose we call it temp, and just copy the same string into it, START. Now what we do, we iteratively go through each character. So initially we are at S. So we check whether the first character in temp is same as the first character in S. If it is true, then we need to replace this S with some other character. So what we will do is, we will go to the next character in temp, which is T, right? Now what we will check is it okay to swap these? That means, suppose this is I and this is J position we're talking about. So what we will check is, if temp of J is not equal to S of I and temp of I is not equal to S of J, like so, then we can swap those, right? So basically what we are trying to find out that which character in the temp can be used to swap it with the ith character. So we can swap it like this. So it would become TSART, like so. Now we go to the second character and then we again check whether this is temp only, whether, let me just write the start here. Now we check whether S and the second character in both of them are same or not. Since it is not same, since we swapped it, we will just move ahead to the next character. And now we find A, which is same as the input string in the same position. Now we will just try to find another character with this formula only. Now, so what we can do is we can simply swap these, right? We get R here, A here, and now we reach to the last T. Now since we can't go ahead, we can start from here again, and if using the same formula we can do the swapping. So if you get a gist of it, let me just try to write a pseudocode. It would make the understanding more clear. So suppose we see in the string S, we create a string temp and have the same value as S. Now for int I is equals to 0, I less than S dot size, I plus plus, if S of I is equal to temp of I, that means we need to swap here. What we will do is we'll create a J. For int J is equals to 0, J less than, not 0, let's just create it I plus 1, or if we think 0 would also work, J is equal to 0, J less than S dot size, J plus plus. And what we need to do is, if S of I not equal to temp of J and S of J not equal to temp of I, then what we need to do is replace them. So we have to swap it. Now we can do it by creating another character. X is equals to temp of J. Now temp of J is equals to temp of I, and temp of I would be equal to X, like so. So once we are done with this for loop, we would have a string in temp which would be the shuffled anagram of this input string S. So simply return temp. I hope you understood the question. You can ask me any question if you have any doubt in the comment section. I would also add the link to my GitHub repo in which I would have added this code, which succeeded in all the test cases in the Kickstart. Thank you for watching. Please consider subscribing.